Now let us see the Oracle database architecture. This Oracle architecture consists of Oracle instance and the Oracle database. The Oracle instance consists of SGA, that is shared global area. Second one is the background processes. Similar to that, the Oracle database consists of physical structure and also the logical structure of the database. The internal memory structure, that is the SGA, consists of database buffer cache, redo log buffer and shared pool, and two optional things, that is large pool and the Java pool. And then we are going to see the PGA, that is private global area. Now let us see database buffer cache. This is used to hold data blocks read from data files by server processes, contains dirty or modified blocks and clean or unused or unchanged blocks. Dirty and clean blocks are managed in lists called the dirty list and the LRU, that is least recently used. Next, free space is created by DB writer writing out dirty blocks or aging out blocks from the LRU. Size is managed by the parameter db underscore block underscore buffers. Let us see what is meant by the LRU. LRU and the database buffer cache. Every time a data block is read from disk, it is placed in the database buffer cache at the head of the LRU list. If a block is already in the cache and it is read again, it is moved to the head of the list. Data not used frequently is aged out of the cache while frequently used data remains. The next is redo log buffer, a circular buffer that contains redo entries. It contains the redo entries reflects changes made to the database. The next, redo entries take up contiguous sequential space in the buffer. Data stored in the redo log buffer is periodically returned to the online redo log files. The size is managed by the parameter called log underscore buffer. The default is 4 times the maximum data block size for the operating system. Next, we are going to see the shared pool. Consists of multiple smaller memory areas. One is the library cache, that is called as shared SQL area. That means it contains parsed SQL and execution plans for statements already run against the database. And also it contains procedure and package storage. The next is dictionary cache, contains name of all tables and views in the database, names and data types of columns in the database tables, then privilege of all users. This is managed via an LRU algorithm, that is the shared pool. The size is determined by the parameter shared underscore pool underscore size. The next one is the internal memory structure, that is the PGA, that is program or process global area, also called as private global area. This is used for a single process, not shareable with other processes, writable only by the server process, allocated when a process is created and deallocated when a process is terminated. And it contains 4 things. One is sort area, that is used for any sorts required by SQL processing. The second one is session information, that is includes user privileges. The third one is cursor state indicates stage of SQL processing. The fourth one is the stack space, contains session variables. The next is background processes. The first one is DBWR, that is database writer, contains writes contents of database buffers to data files. Primary job is to keep the database buffer clean. Writes least recently used, that is dirty buffers to disk first. Writes to data files in optimal batch writes. Only process that writes directly to data files. This is the mandatory process. These are the four steps that the database buffer cache, that is the DB writer, is using to write in the data files. One is the server process cannot find a clean reusable buffer. Second one is a time out occurs, that is the 3 second, and a checkpoint occurs. The fourth, DB writer cannot write out dirty buffers before they have been written to the online redo log files. The next one is LGWR, that is the log writer. Writes contents of redo log buffers to online redo log files. Primary job is to keep the redo log buffer clean. Writes out redo log buffer blocks sequentially to the redo log files. May write multiple redo entries per write during high utilization periods. This is also a mandatory process. Log writer writes to disk when an transaction is committed. A timeout occurs, that is 3 seconds. The redo log buffer is 1/3 full. There is more than 1 megabyte of redo entries. Before DBWR writes out dirty blocks to data files. The next one is SMON, that is the system monitor. Performs automatic instance recovery. Reclaims space used by temporary segments no longer in use. Merges contiguous areas of free space in data files, that is if PCT increase value is greater than 0. SMON wakes up regularly to check whether it is needed or it may be called directly. This is the mandatory process. SMON recovers transaction marked as dead within the instance during instance recovery. All non-committed work will be rolled back by SMON in the event of server failure. SMON makes multiple passes through dead transactions and only applies a specified number of undo records per pass. This prevents short transactions having to wait for long transactions to recover. SMON primarily cleans up server-side failures. Next is the PMON, that is the process monitor. It performs automatic process recovery, that is cleans up abnormally terminated connections, rolls back non-committed transactions, releases resources held by abnormally terminated transactions. It restarts failed shared server and dispatcher processes. PMON wake up regularly to check whether it is needed or it may be called directly. It is a mandatory process. Detects both user and server aborted database processes. Automatically resolves aborted processes. That is, PMON rolls back the current transactions of the aborted process. Releases resources used by process. If the process is a background process, the instance most likely cannot continue and will be shut down. Pmon primarily clean up client-side failures. The next is CKPT, that is checkpoint. Forces all modified data in the SGA to be returned to data file. That is, it occurs whether or not the data has been committed. Checkpoint does not actually write out buffer data only. DBR can write to the data files, that means DBWR. Updates the data file headers, that is, this ensures all data files are synchronized. Next, helps reduce the amount of time needed to perform instance recovery. Frequency can be adjusted with parameters. The next is ARCH, archiver. Automatically copies online redo log files to designated storage once they have become full. Next is the database structure. The first is physical database structure. An Oracle database physical structure is determined by the operating system files that constitute the database. Each Oracle database is comprised of these types of files: one or more data files, two or more redo log files, and one or more control files. The files of a database provide the actual physical storage for database information. The first one is the data file. Data files associated with a table space store all the database data in the table space. One or more data files form a logical unit of database storage called a table space. A data file can be associated with only one table space and only one database. After a data file is initially created, the allocated disk space does not contain any data. However, the space is reserved to hold only the data for future segments of the associated table space. It cannot store any other program's data. As a segment is created and grows in a table space, Oracle uses the free space in the associated data files to allocate extents for the segment. The second one is the control file. A control file tracks the physical components of the database and other control information. It is essential to the functioning of the database. Because of this, Oracle recommends that the control file be multiplexed. In other words, it should have multiple identical copies. For database created using DBCA, 3 copies of the control file are automatically created. The next is the redo log. The primary function of the redo log is to record all changes made to data. If a failure prevents modified data from being permanently returned to the data files, then the changes can be obtained from the redo log, so the work is never lost. To protect against a failure involving the redo log itself, Oracle allows a multiplexed redo logs so that 2 or more copies of the redo log can be maintained on different disks. When Oracle DBA archive your redo log, you write redo log files to another medium location prior to their being overwritten. This location is called the archive log. Oracle DBA can archive to multiple locations including a standby database. These copies of redo log files extend the amount of redo information that can be saved and used for recovery. Archiving can be either enabled or disabled for the database, but Oracle recommends Oracle DBA should be enabled. Then next, logical structure of database that consists of table space, segments, extents, and data blocks. The table space. Each database is logically divided into one or more table spaces. One or more data files are explicitly created for each table space to physically store the data of all logical structure in a table space. The combined size of the data file in a table space is the total storage capacity of the table space. The next is segment. A segment is a set of extents allocated for a certain logical structure. The segments can be on one of the following type: data segment, index segment, temporary segment, and rollback segment. Next is the extent. The next level of logical database space is an extent. An extent is a specific number of contiguous data blocks obtained in a single allocation and used to store a specific type of information. The last is the Oracle data blocks. As the finest level of granularity, Oracle database data is stored in data blocks. One data block corresponds to a specific number of bytes of physical database space on disk. The standard block size is specified by the db_block_size initialization parameter. In addition, you can specify up to 5 other block sizes.